Hello, I'm a fourth-year PhD student here at Stanford, just up the street. I work with my advisor, Anna Mikulik, at the Carnegie Institution for Science. So we do a lot of work looking at remote sensing for, actually this is going to be a new topic, I think. No one's ever talked about this today, looking at freshwater quality in lakes and reservoirs. So I only have a few slides, so it's go pretty quick. Just to tell you what we're talking about here, why we're talking about this, why this is important. Algal blooms are, they indicate important threats to freshwater systems. They've been called, freshwater systems in particular have been called sentinels of climate change. Lake water warms faster than air temperature, so you can imagine effects of global warming are felt more deeply in freshwater ecosystems. And at the same time, these algal blooms, though they can signal large-scale changes in watersheds, they can also be toxic to humans. So there's a health component. Suffice it to say, there's many important reasons why you might want to monitor algal blooms in freshwater lakes. But even though these blooms are really important to monitor, there are very few long-term data sets available to do so.
Imagine going out on lakes, taking samples. That's sort of been the MO so far in this space. This is a picture of Lake Erie, if you're familiar. Right there in the north is Detroit. I think this is Cleveland. This is a harmful algal bloom that occurred in 2011. It was a record-setting bloom. That allowed us to write a really good paper on it. Suffice it to say, these things are getting worse because of climate change, and that means that the importance of generating long-term data sets with which to understand environmental drivers is even more important. So where does Earth Engine fit in this? We use Earth Engine. We use the Landsat archive to generate, to look at historical records of algal blooms in order that we might identify some environmental drivers. So what we did here, sorry, this is also the outline of my dissertation, so this is really important. So I've looked at this a lot. What we did here was apply different algorithms for identifying blooms in a single validation case where we have lots of data. That's Lake Erie, the lake that we just looked at. We identified the best performing algorithms based on the validation data. And we've generated a long-term data set for this one lake. So I think if I'm right. So I told you I'm in the middle of my dissertation. So the first three we've done, and I'm going to show you some pretty pictures about this. And then what we're trying to do next is to scale this up to a big database of lakes, freshwater lakes globally. So there's not, even within this literature, there's not really a consensus on whether or not there are long-term trends in algal bloom occurrence, extent, toxicity, and whether or not those trends are related to things like global warming. So I think I have one more slide. This is some pretty pictures from a paper that'll come out soon. If you can follow from the left to the right, on the left is what we did. We applied different types of algorithms which are just sort of mathematical operations of different bands. Look at different algorithms. So there's like a red to blue ratio, near infrared minus red. The exact titles don't matter so much, but you can see that, for example, in the left two columns, different algorithms pick up the algal bloom in a different way, and we use that to identify the best one. We picked the best one. We generated this sort of historical record. It's not a binary image on the left, but sort of this continuous image. So we can generate, this is a plot of the maximum bloom extent that Landsat sees each year, which is important for measuring things like the nutrient load into the lake and so on and so forth. And then from there, we can generate even more sort of extra time series, and we can generate this kind of seasonality.